Lab 2 lines of charge. So, by charging adhesive tapes through separation and observing their interactions, we can visualize how lines of charge influence the behavior of nearby objects. This experiment allowed us to examine the electric fields generated by linear charge distributions and provided insight into how electric forces act over a distance, thereby demonstrating key principles of electrostatics and field theory. So, the purpose of this experiment was to prepare two pieces of charged tape, which were the same ones from Lab 1, determine the interactions between the clear tapes and other objects, and to simulate these interactions with the computational Python model. So, the assumptions we made here was that there were no air resistance. We treated the pieces of tape like point charges, and the charges on both pieces of tape were equal, and that each U tape had about the same amount of charge, which was uniformly distributed along the length of the tape. And here you can see a free body diagram of the forces acting on the tape. So the fundamental principles we employed: Newton's second law, the formula for electric force, Coulomb's law, a gravitational force, and then the electric field of a point charge here. So the preview of our results: so the charged clear tape had a net positive charge, as we found in Lab 1, and the electric charge of the tape was about 1.25 times 10 to the minus 8 coulombs. So our system we defined to be tape A and B, which was the U tape. The surrounding was everything else, like the books, table, our hands. And the tape length was 0.02 meters. It started at neutrally charged, so 0 coulombs, and 0.02 grams was the mass, or 0.0002 kilograms. So some observations we saw were that the two pieces of tape got stuck to each other. The top piece was rapidly pulled off, thus becoming charged. After charging two pieces of tape and holding them close together, they repelled, which indicated that they had the same charge. And then the tape did keep getting closer to the table or any neutral object, and it attracted a neutral plastic pen after being rubbed in hair, meaning it had a negative charge, so the U tape must have been positively charged. So the distance between the two pieces of tape was 0.024 meters about. We calculated the force due to gravity to be the mass times g, which was negative 0.00196 newtons. So therefore the electric force was 0.00196 newtons. And then the charge of one piece of tape using the line charge model came out to be 5.685 times 10 to the minus 9 coulombs. So this is the computational model that we used to calculate the force, the electric field, and the charge on the tape using a point charge or a singular point charge model, as we did in Lab 1. And then here's the calculation that it got. And then here's what we used for Lab 2 to add up the individual electric forces to find the total electric force along this line of charge. So here you can see each point charge was like a small amount of charge dq, and then you could see it iterating through to add up all the charges to find the total electric charge and force on both pieces of tape. So some sources of error that likely occurred were that the pieces of tape, like our assumption, was probably false because these tapes probably don't have equal charge. Some charge could have been lost during the experiment, and then obviously we could have measured it inaccurately, like the length or the width. And we also could have not placed the U tape exactly parallel to the suspended tape, so that could have also created some error. What if you had modeled each of your tapes as a single point charge, and then comparing these values to the values that we got with the line charge model? So using the point charge model, what our charge that we found was about 1.12 or 1.2 times 10 to the minus 8 coulombs. And then using line charge model, the charge was 5.68483 times 10 to the minus 9 coulomb. So the point charge model actually had a greater calculated charge than the line charge model by like a factor of about 2. Why do these estimates differ? Which value is likely to be closer to the real value, and why? So these differences happen due to the assumption that we made about a charge being uniformly distributed across a line of point charges instead of a single point charge. And the line charge value is probably closer to the real value because it models the charge distribution on the tape more realistically than just a single point charge, since the tape is more of a line structure than just an actual point charge. And yeah, that's it. Thank you.